Hey there, and welcome to exercise number 38. In this one, we need to write a function named rotateArray that receives two parameters. First, an array of items we're gonna call items. It doesn't really matter what you have in the array. You can have numbers, strings, objects, you can mix and match data types. Doesn't really matter for this exercise. The second parameter is a number we're gonna call n. The function should return a new array with the items rotated towards the right by n positions. And below we have a note. So a rotation towards the right means that all elements of the array are moved to the next index, so towards the right, except for the last element which is moved to index 0. And below we have an example. So if our items array is Bob 71 and then this object, if we rotate it 2 times towards the right, we get this order. So 71, then the object, and then Bob. Now, below we have a more interesting example, I'd say. If our items array is an array of strings, Wikipedia, Mozilla Developer Network, Free Code Camp, and Stack Overflow, and n, the number of rotations is 4, the resulting array is in the exact same order as the initial one. So as you can see, we have Wikipedia, Mozilla Developer Network, Free Code Camp, and Stack Overflow. Now, if you want to solve this exercise for yourself, which I highly recommend, click on the link in the description. If not, keep watching. I'm going to go here into the right side, into the code area. And the first thing I want to do is, actually before I start coding, let me tell you a little bit of a disclaimer. So the solution I'm going to code right now in the video is a solution that I think it's a lot easier to understand. It's not the most optimum one when it comes to complexity, but I think it's easier to understand. So we're gonna code this solution, but if you open the help panel, so here, you're gonna see a different one, which is better from a code point of view. I mean, from a complexity point of view. Now, this disclaimer being said, how do we want to solve it? Well, let's first create a function that actually does one rotation. So I'm gonna say rotate once, and it gets some items. So we get an array, we only want to rotate it once according to the definition here. So first let's test, let's treat the scenario in which items is empty. So if items.length is 0, return empty array. Otherwise, let's create a result. This is the new array, and let's first move all items towards the right except the last one. So I'm going to say for I is equal to 0, I is less than items.length minus 1, I plus plus. We should do result of I plus 1, so we move it to position I plus 1 is items of I. So we moved all items except the last one. Now let's move the last one. So I'm going to say result of 0 is result of items.length minus 1. And let's return result. Let's test this function. So console log rotate once of 1, 2, 3. And we should get 3, 2, 1, 3, 1, 2, but we get 2, 1, 2, which is not good. So let's see. I is less than items length minus 1 I plus plus. We put on I plus 1 the element on position I, and then, oh, this is the problem. It's like this. Okay, seems to be working. Let's put 4, 4, 1, 2, 3. Okay, this looks good. Now that we have a function that rotates once, we can apply this function n times. So let's do let result here is, and first we duplicate the items. I'm doing this spread here because I don't want to modify the initial parameter. So I'm going to create a new one. Then let's iterate from I1 less or equal with n, I plus plus. I'm going to say result is rotate once of result. So I rotate result once, I put it back in result. Finally, I return result. Now let's test our code. So I'm going to say console log rotate once, rotate array, and let's put 1, 2, 3, and I want to rotate it 2 times. what do we get? 2, 3, 1. And that makes sense. So let me just write here, because it's going to be something interesting, okay? So we get 1, 2, 3. This is base. Then 1, rotate 1. I'm going to have 3, 1, 2. Then rotate 2 the second time. I'm going to have 2, 3, 1. Rotate 3, the third rotation, is going to be back where we started. That's interesting. Let's test those. So I'm going to put here 3. We should still get 1, 2, 3. Okay. Now, you might notice that if we keep going, at one point, we're going to end right back where we started. And this is an optimization we can do. So for example, if I rotate this 9 times, I'm going to get the exact same order. But I've run this for here for 9 times. I created 9 arrays, so that's really a waste. So let's do a small optimization. And I'm going to say const actual rotations. So the actual rotations is n, the rest, I mean the remainder, I think that's how you call it in English, of n divided by items.length. So for example, if n is 4 and length is 4, then the actual rotations is 0. We don't actually rotate it, I mean rotating it 4 times in this scenario is the same as not rotating it, because we get back the same order, right? If we have 12, again it's 0. If we have 13, well, the remainder is 1. So 13 rotations is the same for an array of length 4 as just doing 1 rotation. So here, by doing this optimization, we're going to iterate from 1 to this number, and actually we're going to get the very, the same result, but we're not going to waste all those time rotating it. So basically, if we have here, let's test it. If I here have 9, you see the same result, 12, the same result, but actually in the back, I never rotate it because it's the same. If I put 14, it should be like 2 rotations, so 2, 3, 1. That's good. Now, I'm gonna stop the video here, and I'm gonna, first let's test the solution. Okay, so it works. Now, as I said in the beginning, this is not the most efficient solution when it comes to complexity. Now, imagine if we have, okay, I cannot write here because this is read only now. But imagine we have 1,000 elements and we rotate it 500 times. This means we create 500 arrays here in the rotate once function. So this is really a waste of resources. Now, the better solution is here in the help section. So I'm gonna let you do this on your own, and you can see a solution which is much more efficient than this one. But again, I've chosen to explain to you this one because I think it's easier to explain. So this being said, cheers and see you in the next one.